Hi guys, welcome to our second video in section 4 dealing with redox reactions. So need your notes, and we'll do a quick review. We'll talk about what redox reactions are, characteristics, and practice. So here we need to remember how to assign oxidation numbers for each element. So here we have FeS, and it's all by itself, so Fe is going to be a 0 charge. And don't forget, don't worry about the coefficients here. Next we have oxygen. It's all by itself, so it's going to be a 0. And next, we have a compound, Fe2O3. So now we have to figure out what the charges are going to be for the Fe and the O. So let's come down here. We have Fe. We know that there's two Fe's, and we don't have a specific rule for Fe, so we'll set this one equal to 0. That's going to be our unknown. We know that there's going to be 3 oxygens, and each of those oxygens are going to have a -2 charge. Since it is a compound, it's neutral. It's going to be an overall charge of 0. So we're going to set this equal to 0. So now we have to figure out what our unknown is. So we have 2x plus 3 times a -2. And remember, that's a times, not an x for a variable. In fact, I will make this a little bit more of a fancier x. So that's equal to -6 and 0. So when we solve for x, it's 2x is equal to 6, so x is equal to a +3. So here, the Fe is going to be a +3, and the oxygen is going to be a -2. Sometimes that gets a little confusing, so it's better to write it out as Fe is +3, and oxygen is -2. Right? So we know going from Fe on the reactant side to the product side, it went from a 0 to a +3 charge. That means 3 electrons must have been lost. When we go from an oxygen on the reactant side to the product side, it goes to a -2 charge. So that means 2 electrons must have been gained for each oxygen. So let's talk about redox reactions. So this is our basic redox reaction. Electrons are gained or lost. We call them redox reactions because it's reduction and oxidation. Let's talk about the oxidation part of it. So electrons are lost here, and there's some kind of funny ways to remember them. One is oil, so oxidation is losing, and then we just assume it's electrons. Or LEO, L-E-O, lose electrons is oxidation. We also have reduction reactions here. So with reduction reactions, electrons are gained in a reaction. So we have RIG, R-I-G, for, let's go back. RIG, R-I-G, reduction is gaining of electrons, or GER, G-E-R, gain electrons is reduction. So you take a look at it. We have oil, RIG, or we can have Leo the lion goes GER. Either one works for me. As long as you remember oxidation, electrons are lost, reduction, electrons are gained. So from some characteristics, actually, let me go back through and let's go specifically and figure out what is happening in here. So we know that Fe is 0 here on the reactant side, so is oxygen. And on the right-hand side, Fe is a +3. We found that out before, and oxygen's a -2. So let's write out some half reactions. We know that Fe went from 0 to +3, so that means that since it increased in its charge, that means electrons were lost. So that underwent oxidation. So here, we'll write out half reactions. This time we definitely need to have the coefficients, so put the coefficients in there. So it went to 4 Fe, and then there's 2 Fe's here, and then times another 2. So we're actually going to make this as a overall coefficient. So 2 times that, so the 2 of the coefficient times the 2 of the Fe, make it 2 Fe. That's good, it makes sense. There's 4 Fe's on the left-hand side, 4 Fe's on the right-hand side. Now we'll deal with charges. This was a 0, this was a +3. So overall, let's take a look. 4 times that 0 charge means that there's 0 electrons over here. Each Fe has a +3 charge, but there's 4 of them. So here, there's a +12 charge. We know that 0 is not equal to +12, so here we have to put some electrons in. Again, we're only adding in electrons here. We're not dealing with protons, so we're only dealing with negative charges. Since on the right-hand side this is a +12, we can add in 12 electrons. Whoops, make that a 12 electrons. So really, that's a plus a negative 12. So 12 plus a negative 12 gives you 0, which is good. That means that you're balanced. So overall, if I asked you to write the half reaction of electrons are lost, this is what I would want. 4Fe produces 4Fe plus 12 electrons. There's 12 electrons over there. Electrons are lost, and in this case the electrons are in the products, if that helps you remember it. So also make that note as well. The electrons are in the products. Let's take a look down below for a reduction. So oxygen went from 0 to a negative 2. That means electrons must have been gained. So let's go ahead and write out the 3O2. Now the reason we're keeping this as like having the subscript is because O2 is all by itself. Over here on the right hand side we did 2 times the negative 2 for the iron because iron was part of a compound. So since oxygen here is all by itself, we can go ahead and make that 3O2 instead. And that's where the trickiest part might be. Everything else is just really easy for this. So let's take a look on the right hand side. Oxygen's part of a compound, so we have to write out the 2 times its 3 oxygens right there. That gives us 6 oxygens. We know that each oxygen is a negative 2 charge. So here overall we have 0. Make that arrow an equal sign. We have the 6 times the 2, so that's a negative 12. We know that 0 is not equal to negative 12, so we have to put some electrons in somewhere. In fact, we're going to go ahead and put them right here. In fact, 12 electrons. So we have negative 12 is equal to negative 12. So we'll put those 12 electrons in, and this is what I would be looking for. Hey, hopefully you noticed this by now. 12 electrons are in the reactants, 12 electrons are in the products. So when we write this, really what's happening is we have 12 electrons here and 12 electrons here. The reason we don't write out those 12 electrons is because they cancel each other out. So we don't actually put them in our chemical equation. Instead, we have to do these half reactions. So we have Fe as one half reaction and oxygen as the other half reaction. So when you're balancing out these half reactions, you want the number of electrons that are being lost equal to the number of electrons being gained. So some characteristics of redox reactions. Redox reactions are going to be single replacement reactions, synthesis reactions, or decomposition reactions. If you need help with this, this was a Unit 4 video towards the beginning of the unit. Double replacement reactions are not going to be redox reactions. So an example here is 2AgNO3 plus CaCl2 produces CaNO3 and 2AgCl. So if you were able to do the half reactions, or excuse me, the charges for this, we know NO3 is a negative 1 charge. That makes Ag plus 1. Ca is in group 2, so it's a plus 2. It balances out so that Cl is a negative 1. Over here on the right hand side, Ca is still going to be a plus 2. NO3 is a negative 1. Ag is plus 1. Cl is minus 1. So when we look at the Ags, it's a plus 1 plus 1. Electrons have not been gained or lost, so that's not going to be it. NO3 and NO3, again, they're both the same thing there. So we wouldn't even go back through and figure out what the N is versus the O. We have Ca plus 2 and Ca plus 2. They have not gained or lost any electrons. Same thing with the Cl. That's going to be minus 1 on the left and minus 1 on the right. So those are not going to be redox reactions. Again, we only want things that have a different oxidation number from the left-hand side versus the right-hand side of the arrow. So let's do some examples and practice ones. So we have ZnS plus Cu plus 2 produces Zn plus 2 plus Cu. So they actually wrote out some charges for you, which is nice. We have ZnS, so we know that this is a solid. It's going to be, and Zn's all by itself, so that's going to be 0. The Cu is already given to you. On the right-hand side, the Zn plus 2 aqueous is given to you, and on the right-hand side, the Cu would be a 0. So now, let's just take the Zn's. We'll deal with just the Zn. So Zn, solid. Leave it a little bit of space. We have Zn plus 2 aqueous. Over on the left-hand side, this is going to be a 0 charge. Over on the right-hand side, that's going to be a +2 charge. Those are not equal to one another. So let's add some electrons in. Electrons are negative, so we're going to put them on the right-hand side, and we're going to put 2 electrons in. So this time we have 2 minus 2 is equal to 0. So that checks out. And below that, we'll go ahead and write the Cu plus 2, aqueous, produces CuS. We already know that Cu is a +2 charge. On the left-hand side is aqueous. On the right-hand side it's a solid, so it's going to be 0. So here you had, and I'll write this one below, 2 is equal to 0. We know that's not equal, so we have to put some electrons in. In fact, we'll go ahead and put them on the left-hand side. Get myself some more space. We need 2 electrons there. So 2 minus a 2, because electrons are negative, so it's going to be -2. So we have 0 and 0, and that checks out. So let's double check to make sure that we have electrons on each side. So on the top, we have electrons in the products, and at the bottom we have electrons in the reactants. That's good, and there's 2 in each, so they end up canceling each other out in the overall charge, or the overall reaction. So this top one, Zn, produces Zn plus 2 electrons, so that's good. And we have to label this as oxidation or reduction. Remember, Leo the line goes Gur. That's what I personally prefer. So Leo, lose electrons is oxidation, and then Gur, gain electrons, is reduction. So in this case, for zinc, it ended up losing electrons. Those electrons were in the product, so this is an oxidation reaction. We'll write it out here. And for Cu plus 2 electrons, electrons were being gained, so this is a reduction reaction. Good. So we have an oxidation and we have a reduction. That's good to go. Right, what I want you to do is pause this and go ahead and practice this one on your own. Right, so hopefully one thing you noticed here was that this equation actually is not balanced. You have to balance it first. So when you do balance it, it ends up having 2 KClO3, produces 2 KCl and 3 O2. So let's go ahead and figure out what the oxidation numbers are for each of these. KClO3, that's a huge compound. Let's go ahead and break that up. So we have K. K is going to be a +1 charge, so we know that this is going to be 1 times a 1, plus Cl. We don't have any specific rules for Cl, so that will be our unknown. There's only 1 Cl listed there, so that will be our unknown there. We do have some rules for oxygen, so let's go ahead and put that in. So there's 3 oxygens, and each of which are a -2 charge. This is a compound, so it should be set to equal to 0, excuse me. So you have 1 plus your x minus a 6 is equal to 0. So you have x minus 5 is equal to 0. So your charge of the Cl over here on the left-hand side is going to be a +5 charge. So Cl is a +5 charge there. We know that oxygen is going to be a -2, and K is going to be a +1. I'm going to kind of get some space going here. Alright, so on the right-hand side we have KCl, so the K is still going to be a +1 charge because it's group 1. And the Cl is our unknown here. So we'll add that. There's only 1 Cl, so that's 1 plus an x. Excuse me, 1 times an x. That's all equal to 0. So if 1 plus an x is equal to 0, so in this case, your unknown for Cl is going to be -1. So Cl is a -1 charge, K is a +1 charge. Now we take a look at the oxygen. It's all by itself, so it should be a 0. All right, I'm going to erase some of this right now, just so that we have some room. So hopefully you got that down for figuring out what the oxidation number is. Now we have to figure out what the half reactions are and balance them. Alright, so we went from K, which is +1, to a K, which is a +1. So we don't worry about K. It doesn't change in oxidation number. It's actually not undergoing oxidation or reduction. Let's take a look at the Cl. We went from a +5 to a -1. Yep, that's something we definitely want to deal with. So C, in fact there's 2 Cls, because now we're going to use the coefficients for these half reactions. each of which are plus 5, produces, and here there's 2 CLs. That's good because we want to make sure that there's the same number of CLs on the left and right hand side, and each of which are a -1 charge. So overall on the left hand side, let's go ahead and write down that's an overall plus 10, and on the right hand side that's a -2. So we know that 10 is not equal to -2. We have to figure out how many negative charges to add and where to add them to. So we know we're going from a plus 10 overall on the left-hand side to -2 on the right-hand side. So we can actually add in 12 electrons on the left-hand side. So that's 10 minus 12. 10 minus 12 gives you -2, and that's also equal to -2. Good. So let's add the 12 electrons in there. All right, and then let's take a look at the oxygen. It went from a -2 to a 0, so we definitely want to deal with that. So oxygen on the left-hand side is in a compound, so we want to put the coefficients all in the front. We have 2 and then 3, so 2 times 3 will give you 6. So 6 oxygens, each of which are a -2 charge, produces, and on the right-hand side, oxygen's an element all by itself, so we can actually just leave it as 3O2, each of which are going to be 0. So on the left-hand side, this is an overall -12 charge. On the right-hand side, we have 3 times a 0, so that's 0. So to figure out where to put the electrons in. So if you have -12 is equal to 0, we can put electrons on the right-hand side, in fact 12 of them, so that way we can balance each other out. So plus a -12, so we have -12 equal to -12, that's good. And if we take a look at the first half reaction, the Cl one, we have 12 electrons in the reactants. If we look at the oxygen, we have 12 electrons in the products. That's good. That's what we want because eventually they cancel each other out. So let's figure out which one's which. For the Cl, we have electrons in the reactants. So if electrons are in the reactants, it's reduction. Hopefully you got that. Reaction, reduction, both begin with R. And here we have electrons in the products, so that's going to be oxidation. We'll squeeze that in. So when I ask you to show me your final answer and box it, this is what I want. I want to see this part of it. When I ask you for the work, it's showing me how you figured out the oxidation number, so the stuff that we had to erase from the last slide, as well as all this other little stuff, so like to figure out the overall charges. All right. So to summarize, reduction. Here you're going to gain electrons, so you have the rig of oil rig in here. So reduction is gaining, or what I prefer, Leo the line goes GER. Gaining is gain electrons reduction. For oxidation, here we have oil, so the oil of oil rig, and oxidation is losing, or Leo for Leo the line goes GER. Losing electrons is oxidation. We need to know how to do the half reactions, and for that we just balance out each of the chemical equations and add in electrons. Have a great day, guys.